Previously, we just learned how to use the completing the square method, and actually completing the square can lead us to this quadratic formula. And this is a really very beautiful derivation in mathematics. This section is actually optional because in the exam, you will not be asked to derive this quadratic formula, but it is good for you to see how completing the square can lead to this quadratic formula. So here, I will actually derive the quadratic formula using what you have learned earlier on. We begin with the most general quadratic equation, ax squared plus bx plus c equal to 0. Instead of working with specific numbers, we're going to use this letter a, b, and c to represent the coefficient. Our goal is to solve for x in terms of these letters, creating a formula that works for every quadratic equation. First, we divide everything by a. This gives us x squared plus b over a multiplied by x plus c over a equal to 0. We're transforming our equation so that coefficient of the x squared become 1. That's like what we did earlier on. Then we move the constant term to the right side. So now we have x squared plus b over a multiplied by x equal to minus c over a. Now this is here where we are setting up for completing the square process. Here's the magic. We complete the square by adding b divided by 2a. This should be in a bracket, and then we square them to both sides. Notice that this is the same exact pattern as before when we learned completing the square. We take half of the coefficient of x, which is b over a. So half of it is b over 2a, and then we square it to get b over 2a. This whole thing, we square it. Now step 4, we just have to write it as a perfect square. The left side becomes the perfect square, x plus b over 2 multiplied by a, and then we bracket up this whole thing and square it. This is the same beautiful pattern we see before, but now we use algebraic expression instead of number. Now the next step is to simplify the right side. We just have to find a common denominator. In this case, we know that the common denominator can be 4a squared. So we now have on the right hand side minus 4ac plus b squared, this whole term, divided by 4a squared. We can change it to be open bracket b squared minus 4ac close bracket over 4a squared. Look at this b squared minus 4ac. This is called the discriminant, and we will discuss this more later. Now we can take the square root of both sides. The left side becomes x plus b over 2a will give us plus minus, remember it's plus minus, square root of open bracket b squared minus 4ac divided by 4a squared. Note that square root of 4a squared will give us 2a. So we can just write it as plus minus square root of open bracket b squared minus 4ac, and this whole thing divided by 2a. After this, we can solve for x. So x will be equal to minus b over 2a plus minus square root of open bracket b squared minus 4ac divided by 2a. And then now we have x equal to minus b plus minus square root of open bracket b squared minus 4ac. This whole term should be enclosed with a close bracket, and then we divide it by 2a.